In this video, you are going to learn about the Thomson's experiment, the Millikan's experiment, and the Rutherford's experiment. Let's look at this way. If we have a battery that is connected to two plates, let's say you have one plate over here, the other plate over here. What happens is you are going to connect that to a switch and then connect it to a battery. For this battery, usually this one is positive sign and this side is negative sign. Okay, so what happens if, let's say this is a 1.5 volt battery. What happens if you turn the switch on? What will happen? Just connect it. Connect to two metal plate. Nothing happened. Once you put the switch on, the negative charge will be lining up over here on this side, and the positive charge will be lining up on this side, and nothing will happen. You can try that. What happens if I increase it to, let's say, if I use a 9 volt battery instead of a 1.5 volt with about 1 cm apart? What will happen if I turn the switch on? Nothing will happen. There's no current going through it. It's actually an open circuit over here. All right. The question is, if I turn it to, let's say, 20 volts, what will happen? Nothing will happen. If I turn it to 20 kilovolts, what happens? Something will happen. If this one is 20 kilovolt, 20,000 volt, once you turn the switch on, that means you will see an arc. You will see something glowing, just like when you see sometimes when people try to start their car when it's running out of battery, and if you get to jumped by the other person, and usually people would like to play with the battery, and if you try to put this pole together, you see the spark. Okay, actually what happened is the spark actually happened right before these two pieces of metal touched, because it formed an arc, and you can see the color and you can feel the temperature. Okay, so this is what happened. When you have a high voltage and put it into two plates like this, the negative charge, something from this side is going to come out and jump to this side. In other words, the current will be running through this circuit. So something is going on. It's arcing. All right. So based on this principle, actually what happened is J.J. Thomson, he's the scientist. Actually, he won a Nobel Prize on this one. So over here, let's say there is a negative charge over here. So we connect this to a battery, let's say 20 kilovolts or other voltage. Okay, so it would be positive over here. Positive over here. This is a ring with a washer shape. So over here, the negative sees the positive supposed to be pulling out, because the charges are very symmetrical, so it will not just bombard and form an arc and hit the metal here. Instead, it's pulling on top and pulling in the bottom, so top and bottom balance out. However, the charge is going to pull out and accelerate out. So this charge can come out and move in the straight direction. J.J. Thomson, he is smart enough to put another two electrodes. For example, now if we connect these two plates and make it, let's say, positive over here and negative over here. So this is connected to a voltage. This voltage, we can increase the voltage or decrease the voltage. It can be 1.5 volts. Any voltage over here is going to affect the direction of this unknown beam, this charge beam. Before, we did not know what this beam is. Later on, we know that this is an electron beam. But before, scientists only saw a beam coming out. This beam, the direction of the beam can be changed by different electric field or different voltage over here. For example, if he turned the positive higher, then it will attract the charge, then it's going to bend in this direction and hit the screen over here. Okay, so this is called the J.J. Thomson's experiment. J.J. Thomson This is called a cathode ray tube experiment. This is the actual device that he made. So the electrode is over here. There are other type of either magnetic field or electric field over here to change the direction of this negative charge beam. The result is that is the discovery of an electron. And the electron is known to be negatively charged. All right, so that is the discovery of an electron. There's another famous experiment that is done by another scientist. His name is Millikan. So how he did it was, he have electrode plate up here, electrode plate down here, there's a container. So we can adjust the voltage. So for example, in this case, I can adjust the voltage so it can have different voltage over here and different voltage over here. What he did was he can spray an oil drop in it by using a plastic bulb over here. When he sprayed the oil drop, the drop is going to carry some static charge. It's going to carry some negative static charge. And the drops will have different size. Just a random spray, it may get different size, but it is negatively charged. Okay, so this drop with different size also carry gravity. If I do not put any voltage on here, that means by gravity, these oil drops with negative charge is going to get down very fast. However, by turning the voltage over here, at some point, it's going to balance. For example, the negative is going to push this negative charge up and the positive is going to pull it up. When this electrical force of pushing it up is equal to the gravity force that is falling down, if those two forces are equal, that means the oil droplet is going to stay here. So what he did was he opened a hole over here, use either we call it a microscope or a telescope, just try to focus on one drop. At the same time, try to control the electric field, the voltage up here. So he could actually balance this drop. By using this microscope or a telescope, he can see the diameter of the oil drop, and therefore he can use the density and to calculate the weight of this oil drop. At the same time, by tuning the electric field, he can tune the force. So what he can conclude is, by doing the oil drop experiment, here is a better drawing. Okay, so he can conclude that the charge and mass ratio, that's what he found out first. And later on, he can find out that an electron can actually have a negative charge of 1.6 times 10 to the negative 19 Coulomb. That's the unit of charge, Coulomb. And also, by this experiment, he can find out that the mass of an electron, that is about 9.107 times 10 to the negative 31st kg. That is very light. Okay, the other experiment that we have mentioned about is the Rutherford's gold foil experiment. Because of those experiments, scientists by then knowing that substance can be made of positive and negative. However, how do they distribute? Can it be like positive, negative? Can it distribute like this? The positive and negative is randomly, not randomly, but optimized with the charge by distributing the positive is next to the negative. So this is one hypothesis. The other one is, would it be the positive inside and negative things going outside, or the negative thing is inside and the positive is going outside? So all those are the predictions of the subatomic molecules. Okay, so what Rutherford have done is, so he used a beam of alpha particle, and here is the gold foil. It's very thin. So based on the structure of positive, negative, if it goes like this, that means it will be evenly, the beam is going to evenly go through it. Okay. However, that was not what he had discovered. what he saw is when the beam hit over here, yes, the majority will get through. That means the majority of the substance, it is empty because everything can get through. Okay. Later on, he also, well, at the same time, he also see that it's scattered at certain angle and repeatedly scattered at those angles. For example, it can bounce back. So what he thought was, this model is not right. This is what happened. So when he looked at this, he came up with a model that an alpha particle beam can go through it because the majority is empty space. Other than that, the reason that it can bounce back because it actually had certain type of collision with the very dense material that is inside. Later on, it's known as a nucleus. Yes, so it hits over here and bounce back. And over here, it can also interact with, not very likely, but it can also interact with electrons and move another angle. Or it can interact with the nucleus with other type of, for example, inelastic collision. So it will move at certain angle, not bounce back. So the conclusion from his experiment is the nucleus, the atom is made of nucleus inside with positive charge, and the negative charge that is called electrons are running outside. With most of the time, there will be free space in it. Later on, when people know about it, and that's how people describe it, when an atom, everything together is like a super ball field, the volume or the area of the nucleus, that is just like the size of an apple. Okay, so that is about the ratio of the nucleus to the whole atom. An electron will be carrying negative charge, will be somewhere in this space. Okay, that is the latest model of an atom.